Hey, welcome back. So this is going to be a bit of an unusual video, and I'll be off camera again for it. I'm going to be applying for a job on this video, and the job has a bit of a unusual um, application process. So first, let's go to the job host. So the job host is by Peter Voss for his company aigo.ai. His mission is to spark AGI. He wants to be the first to spark AGI. But it's a little bit more than that. He wants to spark AGI using his own research, and he has a lot of skepticism about large language models and the sorts of technology behind that, especially when it comes to their kind of race for energy consumption and stuff. He thinks not only is that not the best way towards AGI, but it 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 he says it right here. AI has lost its way and will never get to AGI through these methods. So he's a prolific writer on this, and definitely somebody that would be great to work for. So here's his job post here. I saw it on LinkedIn. So what he wants. So if we look at the job post and read the job post, which we can see some of the commenters appeared not to do because they just replied to the comment post. So let's start by reading the job post. This is AIGO, the company with a direct path to AGI. And this is a post for an AGI cognitive AI software engineer. Are you eager to be a key member of the team making full human level AGI happen? I am. aigo.ai, or aigo, I'm not sure how they pronounce it, has been at the forefront of developing and commercializing cognitive AI technology designed to lead to true AGI. We have recently launched a major new release to accelerate the development of our core AGI technology with the goal of rapidly achieving full human level intelligence. Are you a brilliant, highly skilled software engineer who thrives on tackling complex software problems? I hope so. We will see. Are you deeply motivated to help make AGI a reality? For sure. ChatGPT has been helping me immensely, and I believe in the potential of AGI, and I think the concerns about it are valid, but I am motivated to make it a reality because I really am optimistic about it. Do you find yourself fascinated by the nature of intelligence and how the mind works? And so let's take that one at a time. So yes, absolutely yes, and I've actually had some things kind of go wrong in my mind, especially in my childhood and teens. I think most people have. Yeah, I'm very fascinated by the mind for sure. And are you comfortable thinking like a cognitive scientist? Yes. I'm not sure what that means, but I want to say yes. So let's have this be the first thing to go away from. So a person who is studying and has expert knowledge of thought processes, learning, and mental organization. So yeah, a lot of psychology sort of stuff. I guess. Well, I don't know. Let's read the so cognitive. Yeah. So levels of analysis, interdisciplinary cognitive science and term. Yeah. So I'm a big fan of like Daniel Dennett. I've watched a lot of his lectures. He's probably on here. Yeah, there he is. So the answer to that is also a yes. In this role, you'll be working closely with IGO's chief scientist, which is, I think, Peter Voss himself, to develop cognitive AGI. And Peter Voss, I've showed him on this channel before. Really interesting person, kind of a global citizen. Lived in multiple countries, and then really passionate about health, especially at an older age. So longevity. He's very thin because he's doing calorie restriction with optimum nutrition. But he's in his 70s and leading this company and very kind of a unusual sort of person. So they're looking for a minimum of 2 years of work experience, and they're very unclear about what that means. I am going to turn 40 next year, so I definitely have that. Prior AI experience is not required. Definitely have. Okay, so sounds good. Our approach is fundamentally different from logic, rule-based, or statistical designs. You don't need expertise in full-stack communications, cloud, or security either. The focus is entirely on heavy-duty algorithmic design, development, and debugging. Strong analytical thinking and logical problem-solving skills are essential, and their platform uses .NET Core / C#. So, yeah, I mean, I'm not sure exactly what they're looking for. They're probably looking for a math PhD, but they don't. Yeah, I'm not sure, but again, they're not looking for logic or rule-based or statistical designs. They're looking for algorithmic design. So probably just a straight computer science degree from somewhere would be good. But anyway, we offer a competitive salary, core team, stock options, comprehensive benefits, and a chance to work on the most exciting technology alongside an amazing team. We're based in Austin, Texas, but remote work is welcome. This is not your typical 9-to-5 job. We're on a mission to save the world. So here is how you apply. You review the articles and white paper, not without an S, I guess there's one, on the website, and then you email your top 3 questions. So you can see there's people who have not done that. I hope they're not in the running to be hired since they didn't follow the instructions. So... Oh. Okay, but yeah, I definitely would like to apply in the way as directed. So this is what I'm going to do first. I'm going to take the and I'm going to pause for this because I'm going to pull up my email. All right, so now I have my personal email pulled up, but it's hidden fairly well. So so now we've got the IP address, or sorry, the email address. So next will be okay. So we'll do this application, and then we'll say application. Okay, perfect. So AGI, Cognitive AI Software Engineer Application. And then we're going to say, we're just going to take this, put that in there. Okay, review the articles and paper on our website and email your top 3 questions. And then along with why you'd be a great fit. So these are, we're going to have 3 questions. Okay, and then so then we're gonna have a why I'm a great fit. So then I'll give an answer to that. All right. So what we're gonna do is next look at the resources and the articles and white papers, and they're saying to review the articles and white paper without an S. So hopefully it's obvious which white paper that is. I'm not sure that it will be. Okay, so it's not. There are 3 white papers. So so let's link that here. So we're gonna say white papers. So reviewed white papers. And then we're going to give links to each of the white papers that I've read and reviewed, which will be these. Okay, and then we're going to say reviewed. Where's the application? Oh, here it is. Okay, and then we're going to say reviewed articles. And give links for each of the articles I review. And then we're going to say questions. And this will be 1, 2, 3. And this would be why I would be a great fit. All right, so that looks good to me. So next, let's pick out some articles to review. I'm not sure how many there are. So there's quite a few articles. Oh, you know what? There aren't that many articles. So let me just put all the. Let me just review each of the articles, and then I'll see how long this is going to take. I might do a part 2. And then when I click send on the email, I will do that off camera because I will post this series applying for this job. And then I will include the link to this series in my application. So first, let's just get the articles out. And honestly, like for my own interest, I have read some of these already. So that will be good. I feel like so the other thing I think it's important to note is when this was posted. So this was posted 2 days ago on Monday. So I feel like as long as I get it in by Friday, I perhaps might even be an early applicant. I think the latest I could get it in would be by the 20th. But if I need to take extra time and get it in before Friday, I feel like that would be a very timely submission date. All right. So next, so this is Imagine. There we go. All right. What is AGI? What is real AGI? Okay, and then what is AGI, the not so real version? Oh, and it looks like I'm putting these in the wrong category here, so they aren't white papers. These are articles. All right, so quite a few articles, but we can see each of them are very short. Some of them, yeah, some of them. So the thing is, these are actual papers. Okay, so so he just posts the abstract. Okay, but even the full paper, which we can see here, is not that long. Okay. There. So now I've got the email drafted out. I like that. So let's start with the first white paper. Okay, so this is towards incremental learning in large language models, a critical review. Incremental learning is the ability of systems to acquire knowledge over time, enabling their adaptation and generalization to novel tasks. It is a critical ability for intelligent real-world systems, especially when data exchanges frequently or is limited. The review provides a comprehensive analysis of incremental learning in large language models. It synthesizes the state-of-the-art incremental learning paradigms, including continual learning, meta-learning, parameter-efficient learning, and mixture of experts learning. So that's cool. These are all different kinds of learning paradigms, which is interesting to know. So I'm just going to throw these into ChatGPT because I'm just curious what ChatGPT knows about this or has to say about this. We'll use the beast mode and just throw that in there as I continue to read. So we demonstrate their utility for incremental learning by describing specific achievements from these related topics and their critical factors. An important finding is that many of these approaches do not update the core model, and none of them update incrementally in real time. Yeah, so this is what he says. So GPT, it means generative pre-trained transformer. And that's one of the reasons why he says it'll never give you AGI, because real intelligences are not pre-trained. They respond to new and novel situations in real time with new and novel solutions. So you'll never get AGI from a model that is pre-trained and doesn't update its core model incrementally in real time. The paper highlights current problems and challenges for future research in the field. By consolidating the latest relevant research developments, this review offers a comprehensive understanding of incremental learning and its implications for designing and developing LLM-based learning systems. All right, so this is a paper. I feel like one thing that would honestly, I feel like any valid candidate would be doing this, but yeah, I'm gonna do that and put the real paper there so it's clear that I, my application has some meat. All right, so that's the abstract. That keeps those short, but unfortunately, they are full academic papers, and he wants you to read a lot of them. So I don't know if this is right for me, but you know what, it'll help for sure. So what I mean by that is, even if I don't get the job, or it's clear that I'm not the right candidate or something like that, just reading these papers will help me in other areas, because I am very much interested in AI. All right, but with that, I'll take a quick break. I'll be right back. All right, I am back. Let's make a dent in this and then take a break. So the introduction, section 1.1 is contribution and structure. Incremental learning, IL, is the ability of a learning system to make decisions based on continuously incoming inputs rather than relying only on previously processed data. This allows the system to adapt and respond to changing conditions and user behavior immediately, rather than waiting for periodic retraining. Given the paradigm's complexity, the existing LLM solutions aim to enable incremental learning, but still haven't achieved it in practice. Therefore, this review takes a broader perspective on incremental LLM, which is a large language model, updates, considering them batch, incremental, periodic model updates. Okay. It also differentiates between core model updates and external system updates. So it's kind of not true that the core model doesn't update itself. I mean, it's true that it doesn't update itself, but updates to the core models are released quite often. Thus, the critical review primarily discusses incremental learning approaches, methods, and techniques in large language models, LLMs, that acquire new abilities to solve unseen tasks while preserving existing ones. Distinct from typical systemized reviews, the paper highlights the following key factors. Number one, analysis of topics related to incremental learning in large language models. The paper covers fundamental aspects of continual learning, meta-learning, parameter efficient learning, and mixture of experts learning, including learning from scarce, changing, so like rare, changing, scarce, changing, or non-existent task information, learning multimodal tasks, and learning task sequences. We provide a deeper understanding and highlight the challenges and opportunities in these areas. Moreover, exploring the relationships and synergies between incremental learning and related topics reveals valuable insights into how incremental learning can be effectively integrated into existing LLM solutions. Number two, the second key factor. Comprehensible and compact exposition. This paper recognizes the importance and complexity of IL and describes the concepts, methods, and techniques clearly and concisely. It aims to reach a broad audience, including engineers and researchers. Through brief descriptions, explanations, and references to original works, the paper helps readers grasp fundamental IL principles and their practical implications. Number three, synthesis of essential information. IL is a fast-growing field with information scattered across various fields and sources. The paper consolidates the relevant information about IL, offering a comprehensive overview to interested readers. Synthesis of the latest practical developments aims to guide researchers and engineers looking for a deeper understanding of IL and its potential applications in LLM-based architectures and frameworks. By highlighting these contributions, this paper complements existing related reviews and offers a unique perspective into the current situation and outlooks for IL and LLMs. The paper consulted relevant sources including Scopus, ACM Digital Library, and IEEE Explore Digital Library. The inclusion criteria for each paper analyzed is the practical verification of the proposed approach, describing the solution, learning process, training data, and experimental results. This paper provides critical insights into existing IL approaches within the LLM design space. To do so, we first define the key LLM concepts and notations used throughout the paper in the current section. Section 2 delves into the current state of IL approaches from a unified perspective by categorizing them into three related topics: continual learning methods, meta-learning methods, parameter efficient tuning methods, and a mixture of expert methods. The paper describes the representative examples from different approaches. Section 3 extracts the main findings, so it extracts the main findings with implications concerning the application of IL to real-world problems with an overview of the challenges ahead. The concluding section summarizes these challenges and research opportunities. So I probably do need to take a bit of a break. Let's see what we got on the clock. So we've got half an hour on the clock. I'm kind of not feeling it today. So normally I would break at an hour, but let's do a 5-minute break. So it'll be instant but I'll pause it and be back in a while. All right, I'm back. That was a good break. So let's go ahead and continue with this. So we're reading the first white paper. When you go to the aigo site, you just get the abstract. So I'm not sure if the job post was intending for the entire white paper to be read or just the abstract. I would assume it was the full white paper, because I'm just not sure you would get everything you needed to know just from the abstract. The other thing that was very unclear about the job post is white paper was without an S, and there are 3 white papers posted, so it's very unclear which white paper is meant to be read. But I will demonstrate that I am a good applicant for this job by attempting to read each of the white papers. All right, so this is, and we can go to the duplicate resources here. So we can see the white papers and articles that are listed. So I'm reading the first one, Towards Incremental Learning in Large Language Models, a Critical Review. And I'm on section 1.2, Context and Motivation. LLMs are based on a transformer neural network architecture and produce text in natural language. Transformers introduced the attention mechanism that tracks the relations between words across lengthy text sequences in forward and reversible directions. It pays attention to co-appearances of words as chunks of information in terms of probabilities, not the meaning of those words. Thus, it cannot understand, since there is no reference to the real world or conceptual world to ground as explicit knowledge. Instead, they approximate complex probability distributions on a large number of variables, the context of a word in text, and predict next words by drawing from these probability distributions. That said, it represents domain-specific knowledge as a language structure relying on context-dependent long-range associations, aka parametric knowledge. Over time, the architecture expanded for generating other media, as embedding vectors have become numerical representations of text, audio, image, and video. For example, encoders for different data modalities. We have witnessed the rapid advancements in LLMs that produce plausible human-like content in various domains. Models with these generative capabilities are called foundation models, FMs. They learn about existing data artifacts and use learned patterns to generate new data instances, including text, images, music, design, and motion. Massive models process vast amounts of unlabeled data, prioritizing general purpose applications. These models are then customized to create tools and infrastructure for specific domains. This way, FMs can be adapted across a variety of scenarios. And FMs are called foundation models. Large language models, LLMs, paved the way for many other foundation models by generating meaningful text at scale, including machine translation, automated dialogues, writing assistance, code generation, and summarization. Their content can be easily converted to images, audio, video design, and motion. Many are available through conversational front ends, including OpenAI's ChatGPT, Google's Bard, and Anthropic's Claude. So I use ChatGPT. I pay $200 a month for it, and it's been really the $20 a month has been an extraordinarily good value. 200, we'll see. There are a number of things I want it to do. It should be able to pay for itself if it helps me produce and write a book that I'm hoping to be able to do with it as my kind of ghostwriter. AI aggregators such as Hugging Face maintain LLM leaderboards with benchmarks for evaluating and ranking models using various performance metrics. Okay, so here's this is an interesting one. So it ranks the models. Hugging Face, that's the place to go. Number one on the list right now is Gemini. O1 preview is pretty high on the list. Oh, ChatGPT 4.0. That's interesting. It actually got a higher score than O1 preview. Interesting. But there's the list. At the very bottom of the list, we've got, the list goes down pretty far. So it's, yeah. All right. So table 1 lists fundamental LLM architectures. The encoder transforms input text into a fixed size set of features as words, positional encodings, embedding in vectors for NLU tasks, and NLU isn't defined, including named entity recognition and sentiment classification. So let's plug that into the LLM. So briefly look at, okay, so it's giving those, so NLU tasks. Okay, well, let's just do it in Google. That'll be faster. Okay, so natural language understanding. Yep. Yeah, that's definitely what it is. Including named entity recognition and sentiment classification. So those are two things that pretty intuitively have to do with understanding. The decoder accepts features to produce output text such as dialogue, question answering, and text summarization. Combined architecture encodes the input text into vectorial representation and decodes embeddings to generate output such as machine translation. So there we go, table 1, fundamental LLM architectures. So we've got 3 types in the table. We've got the transformer encoder, which has text features, text dash features. Then we've got transformer decoder, features dash text, and then transformer encoder decoder, text dash features dash text. So the application for the first one is natural language understanding. For the second one, it is natural language generation. And for the third one, it is sequence to sequence tags. So we got the NLU right from the Google search. The next column is learning. Masked language modeling, sequence to sequence modeling. And then the models that do this. So this is interesting. So BERT, DBERT A, LBERT. So the transformer decoder, the natural language generation, language modeling is the learning. These are all the ChatGPT, GPT-4, Gemini, Llama, Falcon Bard, all the famous ones. GLM, T5, BART, those are transformer encoder decoder models, and I haven't heard basically about these other ones, only these. So these are kind of the hot ones right now. So to better understand LLMs, we illustrate its transformer decoder architecture. Yeah, so these are the, so figure 1. It consists of the embedding component, a decoder stack, and a head component with linear and softmax layers. The embedding component transforms NL, natural language text, into numerical vectors or tokens, chunks. The tokens are forwarded to the decoders for subsequent processing. The decoder comprises multi-head self-attention (MSA) and feed-forward network (FFN) modules. The MSA clusters each token by an attention map obtained from two linear mappings of the input tokens as their dot product. And I feel like I remember dot product from the cool thing about reading books on this channel is we can go back to the book and search them. And I feel like I remember dot product. No. I know that dot product has okay, so it's a mathematical. Okay. Got it. And FFN M, which is a feed-forward network, FFN, then processes the tokens. LLMs stand out from other deep neural network DNN architectures in two ways. First, they exhibit the autoregressive pattern, forming the generation task in iterations. Next, they incorporate the attention mechanism, which quadratically scales computational complexity with the input length. At the same time, LLM's inherent computations occur in the attention blocks within each decoder layer. LLMs iteratively generate tokens, words, based on the previous generated sequence. The process repeats until the model processes and outputs the entire input sequence. So figure 1, the transformer decoder architecture left and autoregressive behavior right. So this is probably in the book. Let's see if that's there. Interesting. All right. Well, I mean, this is the this is it as is relevant to network and cloud engineering. So words are going to be quite a bit different, even if it does have the same concepts. All right. So we've got embedding, decoder, decoder out to here, and then decoder linear softmax. Okay. All right. All right, I need a break again, and I'm noticing that I'm only on page 4, and this is 25 pages. The rest are citations, so I'm gonna need to read about 20 more pages, just to get through this single white paper alone. And there are 3 white papers listed, and then there are also articles. So this is going to be kind of a monumental task. I feel like it might be okay to so when is the deadline? Let me ask. When would you like the application? Would you like the application submitted by? I am reading the white papers and articles for my YouTube channel, but it is becoming clear that it may require a week or so of daily reading to get through everything. Is by next Friday okay? Okay, and then I will leave a link to my channel. and I will comment. Okay, and I will take a break. So yep, I'm gonna take another break. I just took one recently, but I'm kind of not geared up for this, and I'm realizing that I should kind of limit myself and get this done over a period of time rather than just trying to cram it all in and submit the application today. So let me earn my break here. I'm going to get down to section 2 related work, and then I'll have earned a break. So typical LLM learning strategies are as follows, and there's citations for this. Citation 4,3. Number 1, pre-training fine-tuning includes unsupervised training with a massive amount of data for general NLP tasks, also known as upstream tasks, followed by supervised training on a smaller amount of domain-specific data for specific tasks, aka downstream tasks. Number 2, instruction tuning involves obtaining a new instruction-financed model capable of following instructions. The model learns new tasks via natural language instructions. It involves actual training of the model by changing its weights. Soft prompt tuning is a case in which the model is frozen and only the soft prompts, learnable tensors obtained through back propagation, added to the input embedding, are learned. Unlike fine-tuning, which involves billions of parameters to train, in soft prompting, there are typically several thousand parameters to train. Similarly, prefix tuning optimizes a small continuous task-specific vector, aka prefix, where subsequent tokens attend to the prefix. It obtains state-of-the-art performance compared to full data training and outperforms fine-tuning in low data training by learning only 0.1% of the parameters. Number 3, prompting refers to figuring out a prompt or user input that will likely yield the best LLM response in a given situation. In other words, conceiving the input to get an appropriate response pattern. No training is involved. For example, the LLM's weights are not changed due to no gradient updates. A prompt is a flexible task specification containing NL descriptions of intentions and examples and expected responses. Various templates have been proposed and resourced as prompting techniques, including zero shot, instructions with task-specific formatting, but without task-specific examples, few shot, which is typically taught as kind of what you want to do, instructions with task-specific formatting, but without that would be zero shot to have no examples. Few shot includes instructions with a few task-specific demonstrations to guide the model's outputs, so no more than 5 or around 2 or 3. Once you feed it too many, you can actually get diminished results because the quality of your examples can be worse and do not help the model. Chain of thought, stepwise instructions with logical context to simulate reasoning, and tree of thought, guidance to select among multiple solutions. In context learning, ICL is sometimes used to refer to few shot prompting as the model learns to address a new task during inference by receiving a prompt containing task demonstrations. Reinforcement learning from human feedback, RLHF, represents an alternative in which the model is refined based on human feedback or corrections. Initially, users express their preferences among different responses provided by the model to the same prompt. Subsequently, a reward mechanism is established. The model enters a reinforcement learning loop, aiming to maximize the rewards by continuously adapting and refining its responses to better match the user's preferences. Ranking the model's responses from human evaluators offers a superior objective function compared to those utilized in pre-training. This method aligns the model's outputs and human values, preferences, and ethical guidelines, AI alignment. A recent study highlighted practical challenges in using RLHF to customize LLM. As misaligned humans, evaluators may hold different goals and values, quality control with difficult oversight, humans making mistakes, issues in obtaining representative data, biased data, and challenges with reward model, misspecification, misgeneralization, reward hacking, and evaluation. This often requires retraining these models, which is impractical regarding computation, time, and privacy. Retrieval Augmented Generation, RAG, is a framework for increasing the quality of LLM's outputs by grounding the models on external knowledge retrieval components to supplement the LLM's internal representation of information. Implementing RAG verifies LLM-based outputs against reliable facts and sources, ensuring users can check its claims for accuracy and trust. RAG helps reduce hallucinations, outdated knowledge, and non-transparent, untraceable content generation process. The resources required by LLMs, compute data, environment impact are enormous as they are based on statistical pattern matching on large quantities of human intelligence outputs. At the same time, LLMs are still out of proportion to achieving human-like intelligence, such as planning, reasoning, and self-verification. IL of knowledge emerging in the real world is essential to achieve human-like intelligence. However, standard neural network and then topologies are hindered by a catastrophic forgetting, CF. Yeah, a limitation that prevents them from learning a sequence of tasks. This issue must be addressed for an NN to successfully adapt to lifelong or continuous learning, a fundamental requirement for AI. Exactly. Two common goals of continuous learning are to learn new tasks from known classes, online learning, to and learn unknown classes, class incremental learning. Rehearsing techniques can avoid CF, and I don't see CF being catastrophic forgetting. This implies that when new data is introduced, the neural network gets retrained on some previously learned data. However, previously learned knowledge may not be available for such retraining in general. In addition, catastrophic forgetting may occur when compensating for concept drift. Deep learning, DL, assumes that a training set is a representative sample of the underlying unknown distribution. If the distribution space shifts, new modeling should expand this shift. If the initial space is merely shifted instead of adjusting the size of the distribution space, then catastrophic forgetting will occur. I feel like this, if you're going to highlight one thing from this paper, this would make sense. So let me let me make a section called temporary notes. Okay. And you can't do that with a pre-trained model because it can't update itself in real time, right? So like you have to have something different than the model. Like the model's always going to catastrophically forget because it can't. I mean, it can do RAG. It can, and like the new ones do RAG. Like it reaches out to a memory database that it builds. So like if we go to customize, oh, so if we go to, it should be under, yeah, memory. Yeah, so it builds a memory database as it goes, and then it uses rag to call out and load in those memories. So like it can do that, right? Well, this might be a good question. This might be a good question. Let's yeah. So let's put that as a question. So temporary notes. So what is the limitation of the current models when it comes to CF? Does RAG and a memory system, is it, so what is the limitation of the current models when it comes to CF? Is a RAG and a memory system enough to overcome this limitation, or is the fundamental concept of having a model pre-trained something that causes CF to always be an issue? Okay, so I guess that could be my first question. Okay, so the current situation inspired us to look deeper into existing work on topics related to IL, which remember stands for incremental learning, in LLMs, including continual learning, meta learning, parameter efficient learning, and mixture of experts learning, and the challenges posed by the extensive parameterization of LLMs and continual model adjustments to address deficiencies and or undesirable behaviors. So that's it for section 1 of this paper. So I got to page 5. I need to read 25 pages to get through this one paper, and there are 3 papers out there. I'm not sure how long the other 2 are. That might be worth just briefly looking up. All right, so this one is 200 pages. Okay, well this one is 10 pages, so that's good news. This one is 8 pages. Okay, so you know what? By the end of next week is probably achievable. But so I'm about at the hour mark here. Let me take another kind of quick break and see if I can perhaps do a bit more. I feel like I'm a little bit. I want to take my time with this. I can't get it done all in one day. So I want to. I have other things on my list. I have one other thing on my list to get done today where there isn't a flexible deadline. It has to get done today. So I'm going to end the video here, and hopefully I can come back and put another dent in this later when I have higher priority things done and when I just feel kind of more up to it. Let me check the weather. Okay, it's 62 outside, but it's quite sunny outside. Okay. All right. That might help me feel up to it if I get some sun. But anyways, yeah, that's it for this video. This is going to be part of a job application. We'll see if he's one of those people that responds in microseconds to anything posted anywhere online. Nope. So it might take him a while to get this answer, but we will see. Yeah. So. All right. Okay, so yeah, so we'll see. I can't imagine that he expects people to have this, same day he submitted the post to have all the reading done and the questions asked and to put that in. And then I can't imagine that he would want to hire somebody who isn't even aware that these white papers are abstracts that link to larger writings. So that's going to be it for this video. I hope to do more on this series. I will be focusing on this series going forward until next Friday, even though I have some other series started. So thanks for watching, and see you in the next one.